Hello and welcome. Today we're going to be talking about simple interest and how money works. So, interest can be thought of as a fee. Now, a lot of us have dealt with interest in some way in the past, whether it be you get interest by depositing money in a bank and letting it sit, and the bank will pay you interest. Or if you bought a car, then you know that when you pay back the loan on the car, you pay back more money than what you borrowed. That extra money is called interest. So it can either be charged on a loan, something that you're going to have to pay, or it could be earned, like on an investment in the bank. When you break it down, it really comes down to interest is money that is paid to use someone else's money. So if you're buying a car, you're using the bank's money, you're going to give them all of that money back along with some extra. And if you have a savings account, the bank is actually using your money. So sure, you give it to them and they store it, but they're actually using it to do home loans and car loans and other things. So they're making money on your money. And in return, they pay you some interest. Okay? Simple interest is calculated once over a set period of time, and it usually applies to auto loans, short-term loans, small investments, etc. We're going to be using some variables here. All of these variables that we have, this I, P, R, and T, each one of them means something different. I represents the interest. P is your principal. Principal, that's the initial amount of money that you're starting with. And by the way, I is not interest rate. I is the actual amount of money. R is your interest rate. It's usually annually, but it can be other things. We'll look at some of those problems. And then T is our time, oftentimes in years. Lastly, notice that the rate and the time can be yearly, weekly, monthly, daily, etc., but it does have to match. So if you have an annual interest rate and your time is in years, then you're good. If you have an annual interest rate, but your time is in months, we have to do some conversions. Now, for these conversions, we have to use that 1 year is equal to 12 months is 365 days. Now, I know that might seem pretty straightforward, but believe it or not, there are some, it's perfectly acceptable that you'll see some banks don't use 365. They actually use 360. So just be aware that depending on what you're doing or who you're doing this with, they may use 360 for a daily interest rate. They may use 365 for a daily interest rate. We, however, will not be using 360. We are going to stick with using 365 days in a year. So you can see that the way that this formula works, this I equals PRT, just tells us that we're going to be multiplying the principal times the rate times the time. So as any one of these gets to be larger, you can see that the interest is going to be affected by that. If you have a very large principal, meaning you start out with a lot of money, then your interest is going to be higher. If you have a high interest rate, your interest will be higher. If your time is very long, then your interest will be higher. Okay. So let's go ahead and do some calculations here. Each time I'm going to start out by writing I equals PRT. The principal is $2,000. Our interest rate is 4% per year. And our time is 2 years. Find the simple interest. So when it says find the simple interest, that means that I is the thing I don't know. I should know all of the other variables, the P, the R, and the T. You can see they are given to us. Our principal is 2,000, so I'll put that in here. Our rate is 4% per year. So the one thing I want to point out is this is 4% per year for number of years. We're good. What I am going to do is get rid of 4% and write this as 0.04 so that we're using this as a decimal. So I'll put 0.04 in for R, and our T is just 2. We have 2,000 times 0.04 times 2. There we go. That gets us $160. So our interest is $160. That's it. If you have a loan for $2,000 at 4% per year for 2 years, then you would have to pay back the $2,000 along with $160 extra dollars. Let's go over to number 2. Interest is $288. Principal is $1,200 per year. Find the time in years. So this time, I equals PRT. Notice that what we're trying to solve for is the T. It says find the time in years. So what we're going to do is divide both sides by PR. So that really what we have is just T is equal to I divided by P times R. Now, if you want to put all the numbers into the I equals PRT, you can, or you can solve for T first and then put your numbers in. We'll put 288 in for the I. The principal is 1,200. And our rate, I know it says 8% per year, but remember we're going to write that as a decimal, so it's 0.08. So I'll put that in for our R, and that's how we get T. 288 divided by 1,200 times 0.08. This gets us 3. So T is equal to 3, or in other words, 3 years. I know it's years for a couple reasons. One, it says find the time in years, but also our interest rate is per year, and our rate and our time always need to be, they always need to be matching. And let's go down to number 3. We have I equals PRT. This says find the simple interest. So this time, our I is already all alone. So all we're going to do is substitute all of the numbers in for the variables. The next thing I notice is that this is 3% per year, and we are using this for half a year. So our time periods match. We're good. We'll just go ahead and substitute these numbers in for the variables. Say 500 goes in for the principal. The rate, we use 0.03, and our time will be a half a year, or 0.5. That does get us then 7.5. Now that doesn't seem like a lot, and it's not, but I'm not going to leave this as 7.5 because we're dealing with money. So I'm going to write this as $7.50. Just makes a lot more sense to write it in dollars and cents. This is a relatively small loan. It's only $500. It's a low interest rate, and it's not for very long. So the interest will not be for very long. The next one says find the annual simple interest rate. So this time we're solving for R. Let's go ahead and write our formula. I equals PRT. And if we want to solve for R, we can divide both sides by PT. This will get us our interest rate to be I over PT. We'll substitute our numbers in. So our interest, 225 goes in for the I. That goes on top. The principal is 1,500. And our T, our time, is 5 years. And that will get us our R. Notice that on my calculator, this looks almost exactly like how I wrote this out as well. This does get us R equal to 0.03. And then when we change that into a percent, I might say something like this. Say my rate is equal to 3%. Because the question does say find the annual simple interest rate. And we'll usually express the rate as a percentage. The next one looks a little bit different, just a little bit. Let's see if we notice what it is. It says we have a principal of $890, a 3.5% per year interest rate. Our time is 65 days. Find the simple interest. Well, to start out with, we have I equals PRT, and we have my principal, my rate, and my time. Find the simple interest. We should be good because the simple interest is already isolated, but notice that this is 65 days and this is per year. what we need to do is to make these work together. We need these labels to match. So what I'm going to choose to do is to take this and write this as 0.035, and that's per year. So if I want to change that into per day, what I would do is take 0.035 divided by 365. This is my daily rate because there's 365 days in a year. So that's going to be my R that I just put in there. So let's go ahead and substitute all these in. I have I equals P, that's 890, times R, which I'll use 0.035 or 0.035 over 365, and then times my time, which is 65 days. Okay, we'll grab the calculator. This gets us 5.547. Now remember, I is interest, not interest rate, it's interest. That means it's an amount of money. And so this will be $5.47. Again, that seems like a relatively small amount, but this is a very low interest rate and it's for not very long. It's only about 2 months' time. So it should kind of make sense for us to have a low amount of money for the interest. The key to this problem is making sure that you're able to write the rate in terms of days so that you have a daily rate, and then we can use that 65. The next one, you'll notice we do have the same kind of problem going on in that we have 3 months and it's a per year rate. So we're going to have to change those around to make sure that they match. First thing I'll do is I'll write this as 0.06 per year, and I want to change it into months, so I would say 0.06 over 12 equals our monthly rate. And I'll just leave it like that. Now this does work out okay, but I'm just going to leave it as 0.06 over 12. That's how I'll write it as well. We also know that we have I equals PRT. There's nothing wrong with putting your numbers in right now if you want to and solving. I'm going to choose to solve for the principal first. I want to isolate that P. I'll do that by dividing both sides by RT. So now P is equal to I over R times T. Let's substitute our numbers in. $6.75 is the interest. The rate is 0.06 over 12, and the time is 3. That will get us our original principal. So once again, you can see I have it in my calculator so that it looks almost exactly how I wrote it. And then what I have is my principal is equal to $450. All right, let's keep going. This time we're finding the simple interest, so good news. We don't have to adjust our formula at all. I equals PRT. If we're looking for simple interest, that's already solved. But the other nice thing about this, I don't know if you noticed it already, this is 1.4% per day for 15 days. These already match. We have a daily interest rate for 15 days. That means we're good. We can just substitute these numbers in just like they are. Well, almost. 1.4%, I'm going to write that as 0.014. Because remember, we need to change that percent into a decimal. If you kind of forgot about that, 1.4% quite literally means 1.4 per 100, which would equal 0.014. I've just been moving the decimal over two places. The principal is 25,000. Our rate is 0.014 per day, and our time is 15 days. I don't need to divide by 365 because this is already a daily rate for a number of days. Our labels already match. 25,000 times 0.014 times 15 gets us 5,250. Now, my initial gut reaction is that, wow, that's a lot of interest. $5,250. And it is. That is a tremendous amount of interest for only a 15-day loan. The thing that makes this what it is, though, is 1.4% per day is a lot. Like, it's criminally a lot. Like, we're talking about like a 500% annual interest rate. So that's like mob type loans here. So if you don't pay this back, you might get some broken hands or fingers or something. But like, don't take this loan out. This is a crazy high interest rate. Again, that feels like a lot, 5,250, and it is. That's because 1.4% per day is a lot. In fact, 1.4% per day means $350 every single day that you have this loan out. Our next problem here, when you look at this, you can see that we do have a time in months, and it does say to find the annual simple interest rate. That means we're solving for R. So when I take I equals PRT and I want to solve for the R, I've got to divide both sides by PT. That's going to get me R is equal to I over P times T. So that's easy enough. We can start substituting our numbers in. I'm actually going to show you two different ways to do this, and that's because this shows us, there we go. This shows us that we want an annual simple interest rate. So R is equal to 420 over principal 7,000 times 9. Now, keep in mind that 9 is in months. So we'll do 420 divided by 7,000 times 9. This gets us an interest rate that looks like this. A lot of sixes, like that. But this is monthly. So we need to multiply this by 12 to get to annual rate. So I'll just take that number and say times 12. There we go. Now we have our rate to be 0.08. When we change that into a percent, this will be 8%. I said that I'll show you another way to do that. So if we want annual simple interest, what we could do is to change the time to be in terms of years. Right now it's in terms of months. But if I take and write this 9 months as 9/12ths of a year, now my time is in years. And if I substitute my numbers in, 420 over 7,000 times 9/12ths, we'll go ahead and put this all in the calculator. You might even be able to see on my calculator how this is going to work out. So 420 1,000 times. There we go. We also get R is equal to 0.08 or 8%. We still get the exact same thing, just solving for it a slightly different way. So figure out which way makes the most sense to you and do that. That's just fine. A small clinic takes out a loan for $120,000 to purchase a new x ray machine. The loan has a simple interest rate of 7% per year. How much interest will the clinic owe after 36 months? Notice that those time frames do not seem to match. So the first thing that I'm going to do is take this 36 months, and I know that there's 12 months in a year. That means that this will be 3 years. So I'm going to scratch this out and make sure that I don't use it. I need to use 3 for my time. I could have changed my interest rate into a monthly interest rate. This just seemed to make more sense to me this time. So if I use I equals PRT, says they took out a loan of 120,000. That's going to go in for my principal. My rate is 7%, and that will be a decimal. And then my time will be 3 years. So we'll just substitute all those numbers in. Make sure to use 0.07 for your rate. And now we're ready to grab our calculator. This gets us $25,200. So the interest on this loan after 3 years' time will be $25,200. When they pay back this loan, they're going to have to pay back the original $120,000 along with $25,000 of extra money because they wanted that x-ray machine right now. They couldn't wait until they had the $120,000. They had to use the bank's money. A dental clinic paid $1,800 in interest on a $15,000 equipment loan after 2 years. What was the annual simple interest rate? So we're trying to find a rate, that's our R, and it is an annual rate. I equals PRT. We'll just start substituting in the things that we know. They paid $120 in interest. That's going to go in for I. They pay $15,000 loan. That's the loan amount. That's the P. And then our time is 2 years. So this time you'll notice I didn't solve for R first. This is what it looks like. If you just want to substitute all the numbers in, you can. Next, we'll divide this by 15,000 times 2 on both sides. That will allow the 15,000s to reduce out. That allows our 2's to divide out. And that leaves us left with just R. And on the left-hand side, we have 1,800 divided by 15,000 times 2. This does get us an interest rate of 0.06, or in other words, 6% interest. If you wanted to, you absolutely could have done this like we did the other ones, which was to solve for the R first by dividing by P times T. Hopefully you can look at this and see how, yeah, it really is the same thing to do it either way. We're just substituting in the correct numbers in for these variables, but we're still taking the interest and dividing it by the principal times the time. Next, let's look at Lisa. Lisa's going to buy a new car. It's $55,000, and that's with the taxes and the plates and fees and everything. Using an auto loan that charges daily simple interest, the annual interest rate for the loan is 6% interest. So there's a lot to this problem. Let's start exploring it. Convert the annual interest rate into a daily interest rate. Okay, well, that's easy enough. Tells us that our annual interest rate of the loan is 6%. So we could take 6% and then divide it by 365 because there's 365 days in a year. 6% is the annual interest rate, and if we take 6 and divide it by 365, we have a daily interest rate of 0.01643 percent. That'd be probably 0.64 if we round that. Now, whenever you're doing these, I realize that you have a decimal and we can use it to calculate. We're actually going to not round until the very, very end of a problem. For part A, it says convert this into a daily interest rate. So you can either write it like 0.01644%, or you can change that into a decimal. Yikes. I think that it makes more sense to say that the daily rate is 0.01644%. Now, as we continue through this problem, I'm not going to use this rounded number. Okay? Using the daily interest rate, calculate how much interest accrues on Lisa's loan in one day. So instead of taking 55,000 times that daily rate for one day, what I will do is take 55,000. Oh, sorry. This is because I equals PRT. So 55,000 is our principal. Our rate I'm going to use as this 0.06, that's the 6%, divided by 365. I'm not going to use the rounded number that I already calculated in A. I'm going to use the exact number. That's what I'm using. And then our time is for one day. So we'll take 55,000 times 0.06 divided by 365, and then times 1. You don't really need the 1, but what this does do is it gets us the amount of interest for one day. This will be $9 when we round to the nearest penny, $9.04 per day. Let's keep exploring this problem. The next thing that I see, it says convert the annual interest rate to a monthly interest rate. Well, this is relatively easy. What we have is 6% per year, and if we divide this by 12, we now get 0.5% per month. That's our monthly rate. Use the monthly interest rate to calculate how much interest accrues on Lisa's loan in 1 month's time. Well, we'll still use I equals PRT. Our principal is still 55,000. Our rate will be 0.5. Oh, sorry. We need to change that to a decimal, which will be 0.005. And then we want that for 1 month now. Okay, I had to use 0.005 because 0.5% as a decimal, we would take that 0.5, divide it by 100, and that gets us 0.005. So that's the number that's going in here for the R. Notice that we have a different number here. Oh, sorry. I'm jumping ahead of myself. So this is $275 per month. So on a car loan, on a $55,000 loan of 6% interest, which 6% is a pretty good interest rate right now anyways. So this would be $275 a month just in interest. Now let's keep exploring this though. Estimate the interest accrued in 1 month by multiplying the daily interest rate from part B, okay, by 30. So if I take this $9.04 per day, and we multiply that times 30 days, this will get us a typical month. There it is. So I get 271.2. Now, there is something else that I want to point out though, is instead of using 9.04, I probably would want to use the whole equation up here. That way I'm not using some rounded numbers. Okay, so this is 271.20. I'm going to get something that's really close to that. Not quite the same. I get 271.23 now. And yeah, that is a little bit different than if we just take 9.04 times 30. Now, we're going to still keep going, and because this isn't necessarily the point of this problem, but you can see that if we take that daily interest rate times 30, we get 271.23, but our monthly interest rate from up here is 275. So there's a difference here. And what we were going to talk about is why there's a difference. How do these compare? Well, the one in Part D is a little bit more. We're off by a couple dollars. The reason why these are off is this 275, that's like an average monthly payment. But we know that not all months have 30 days. So if you were to do this times 31 days, you would actually end up closer to $280, which would be above 275. So some months have 30 days, some months have 31 days. And then, of course, there's February that's a little bit weird. So when car companies calculate your mortgage payment, they do typically calculate it per month. And then if you ever want to pay it all the way off, you have to call them and they'll give you the daily rate, or they'll give you, like, if you want to pay it off on a certain day of the month, they'll calculate that number of days. But in general, they do use the monthly interest rate for this. It's different because 275 is an average month as opposed to just 30 days. Next, Lisa has to decide whether or not she wants to do a 5-month loan or sorry, a 5-year or a 6-year loan, 60 month or 72 months. So with the lower number of months, you can see the payment will be a little bit higher, right? Because if you're paying it off sooner, you've got to pay a little bit more per month. So it says that use your answer from Part E combined with a monthly payment to calculate the remaining loan balance after the first payment is made. Okay. So let's first do option A. That's the 60-month loan. Well, we know that she's going to be paying $275 in interest. We're just going to use the monthly amount that we found. Now, the way that these work is she borrowed $55,000 and she has to pay, this is accruing interest. So in 1 month's time, her loan will accrue $275 worth of interest, which means that if she wanted to pay the whole thing off, she would have to pay off the original $55,000 plus the $275 worth of interest that have happened in the last month. And that gets us $55,275 total. This would be her payoff if she just decided, hey, it's been 1 month, I want to pay the whole thing. But she's not going to pay the whole thing. She's going to pay $1,060. That's her monthly payment, which means that after she made her first payment, she will still owe $54,215. You might think that all you have to do is take the 55,000 and subtract off the 1,060, but that's not how this works because interest happens. You have to pay the interest. If you're using someone else's money, then you got to pay their interest. Okay? Well, let's look at her other option here. For option B, her monthly payment is $900. That's fine. She still had to pay $275 in interest. Like, it doesn't matter how long her loan is, it's still 6% annual interest rate. So we'll still take our 55,000 plus that 275, So if she were going to pay the whole thing off, she would have to pay $55,275. But she's not. She's only going to pay them $900, which means that after 1 month's time, she still owes $54,375, which again, this should make sense. She paid a smaller payment. She only paid $900 a month instead of $1,060 a month. So she paid less, so she still owes more. Okay, that's just 1 month though. Let's look at what happens the next month, because this is where things start to get a little bit interesting. Use the previous results to calculate the interest that will accrue over the next 1 month for each loan. I know you just might say 30 days, but let's just use 1 month so as to not be confused because we're doing monthly payments. So the first payment, or the option A, was $54,215. Remember, this is her principal now. Like, this is how much money she owes. She has to pay 1 month's worth of interest. So we're going to take this times point oh, no, let's write it the way we did before. So we use 0.06 over 12. There's our rate, and we're doing this for 1 month. This time she has $271.08. So notice that the amount of interest has gone down. Remember, originally she paid $275 in interest. Now this month she's paying $271 in interest. The reason is because her principal's gone down. She made a payment, so she owes less money, which means that in the same amount of time, she's going to owe less interest. So as you make payments, the amount of interest that you pay will begin to decrease. Let's look at option B now. She originally had her $55,000 loan, and then after she made her payment, after 1 month, she still owed $54,375. Her interest rate is still 0.06 over 12, and her time is still 1 month. We'll go ahead and put this in the calculator, and we get 271.88. Notice that her interest is a little bit more. Because she made a smaller payment in the first month, her principal of $54,375 is bigger than it would be for the 60-month, $54,215. Because she has a larger principal here for option B, the amount of interest that accrues is larger. Not by a lot, but in the long run, this is going to come out to be pretty substantial because she's making less payments. So it's going to take longer to pay this off. And that's really the reason why a longer loan is going to have more interest accumulate. When you're making smaller payments, you just have more time for that interest to accrue. Now, let's go ahead and look at the last one here. Lisa decides she can afford a $1,500 a month payment and wants to know how much will she pay in total interest. This is a little bit different now. She's not saying, like, what she's doing is she's basically paying extra money every month. And in order to calculate this, what we would have to do is we'd have to calculate the amount of interest in the first month, add that on to her total amount. So we could do something like this and say that it's the 55,000 plus 275. That gets us, she owes $55,275 after the first month. And then we can subtract off her payment and get the new amount. Let's see here. 53,375. This is her next month's. Notice this is quite a bit smaller than the other one. What we'd have to do then is to take that times, oh man, I hope you're not writing all this down. 0.06 over 12, and then we'd have to do that for 1 month. Get that amount of interest, add it on, subtract her payment, get the new interest, add it on, subtract her payment, calculate the interest. That's a lot. What would be required to do this by hand? A lot of perseverance, a lot of dedication, because you're going to just have to keep going until this number reaches zero. So I don't know how long that's going to take. I mean, it's probably going to be like 45 payments. So if you're going to do this by hand, this simple interest calculation, which all of a sudden is not sounding simple, that just sounds like a mess. There are other ways to do this, and we'll explore those later. You can also go to a Google Sheet, if it's still up, and play around with this, and you can see when you have to do a repeated process over and over and over again, wow, spreadsheets are really great for that. So I would encourage you to go play around with this if you want. Spreadsheets like Excel or Google Docs, they're great for Google Sheets, sorry, just doing the same thing over and over and over. It's awesome at that. All right, well, remember, the bottom line is interest is extra money that's paid to use someone else's money. Sometimes that interest benefits you, like if you're loaning money out or it's an investment, then people pay you interest. And other times, interest kind of sucks. Like when you have to pay interest on a house, the interest on my house might be like $600, $700 a month just in interest. And over the life of a loan for a house, you might pay hundreds of thousands of dollars in interest. So it can feel overwhelming. But the better you understand it, the better that you can use it and navigate your way through life without being taken advantage of. I hope this was helpful. Keep practicing your simple interest, and we'll move on to something a little more complicated in the future, like compound interest and annuities and investments. Have a great day.